So let's start into Unit 6 talking about model checkpointing and early stopping. To motivate why we care about model checkpointing and early stopping, suppose we train the following model. On the left-hand side you see a loss plot where we have the training loss and the validation loss. So the y-axis shows the magnitude of the loss. And here on the x-axis we see the number of epochs. As we can see, the loss goes down during training, which is what we want. On the right-hand side you see the accuracy plot. So we have the training accuracy and the validation set accuracy. Here, the larger the better. So you may notice that the model becomes worse over time here due to overfitting. So you can see on the left-hand side this gap between the training loss and the validation loss, and there's also on the right-hand side the gap between the training accuracy and the validation accuracy. By the way, if we are curious about mitigating overfitting, this will be a topic for a later video. So don't worry so much about reducing overfitting for now, we will revisit this topic later. But coming back to our plot here, there's one interesting aspect that we can observe. Assuming for simplicity here that this is not an outlier due to noise, what we can see here is that the previous epoch is actually better than the last epoch in terms of the validation set accuracy. Or in other words, now the model from the last epoch is likely not the best model here. And let's suppose we are interested in obtaining this best model from the second to last epoch. So how could we actually obtain this model? One brute force way would be to rerun the whole training with one fewer epoch. And this is called early stopping, where we have a reduced number of epochs and we stop the training early. So using model checkpointing, we can actually save the best model during training, so we don't have to rerun the training. So how can we achieve that, and how can we save the best model during training? For that, we can use the model checkpoint callback implemented in Lightning. So here, via setting save top k equals to 1, we can save the single best model during training. We could technically also save multiple models, for example the top 3 models, by changing this parameter from 1 to 3 if we wanted to. However, for simplicity we are only saving the one single best model here. Then we have to specify how the best model is determined. So here we are using the validation set accuracy, and we are saying that the maximum validation accuracy corresponds to the best model. Similarly, we could also use the validation set loss. However, then we would have to change the mode from max to min, because the lower the loss the better, and the higher the accuracy the better. And since the higher accuracy is better, here we have the setting to max. And by the way, if we are using a validation set accuracy here for logging the model, we also have to keep in mind that we have to define it as part of the logging procedure. So how can we then get this best model after training? So suppose the training has finished after calling trainer.fit. We can then evaluate the model on the test data using trainer.test. In the trainer.test method, we can specify the checkpoint path. By setting it to best, we can then evaluate our best model on the test dataset. So in this case, the best model has an accuracy of 86.2%. And by the way, for reference, we can also evaluate the last model here by setting the checkpoint path to last. And as we can see here, the performance of the last model on the test dataset is slightly worse than the performance of the best model. Alright, so in this video we covered model checkpointing and early stopping in a nutshell. In the upcoming video we will see a coding example where we will use model checkpointing in action.